This is a lightning talk for controlling epidemic spread, reducing economic losses with targeted closure. So inspired by the lockdown policy in different cities, in this paper, we introduce a framework for studying the optimal targeted closure, which captures the population movement and the heterogeneity in economic values and infection rates in different neighborhoods. Further, we introduce the optimization formulations for both the large infection regime and the small infection regime. Finally, using our framework and the technique, we do an empirical study for the New York City against the COVID-19. Our model is built on the meta-population SEIR model from the mathematical epidemiology literature, where a city will be divided into n nodes, and the population in every node will be subdivided into 5 compartments corresponding to the state against these diseases. And then we construct a network for those nodes, which characterize the movement of the population across different nodes. And the social planner can choose the permitted level of economic activity, in other words, the closure level at each node, and which will reduce the flow to that node and further reduce the infection happen in that node. The social planner have the following 2 different tasks. In the large infection regime, where the number of current infection is large, the goal of the social planner is to decrease the infection in all nodes with the minimal economic loss. And here we show that the optimal policy can be solved by a linear program. On the other side, in the small infection regime, where the number of current infection is close to 0, the goal is to prevent an epidemic or a second wave of these diseases, again with a minimal economic loss. Here we show that the optimal policy can be solved by a semi-definite program. Finally, we applied this framework and technique to do an empirical study for the New York City against the COVID-19. And we construct the following network. The nodes contains 219 zip code tabulation areas in New York City, and as well as 10 neighboring counties. And we measure the economic activities by the number of employment in each node. And finally, we characterize the movement of the population in this network using the aggregate mobile devices movement data from SafeGraph. And here is some example conclusion we get from this empirical study. In the optimal policy, it will permit some economic activity in the Midtown Manhattan while imposing closure elsewhere. And the optimal targeted closure policy will facilitating 4 to 6 times more employment than the uniform closure policy. And the coordination between the New York City and the neighboring counties will reduce considerably economic loss cost within the New York City. And that's it. Thank you.